Precious Kolawole. Uh, Precious is an adept data scientist. She's proficient in machine learning, deep learning, and software engineering for data science, with a track record of products and solutions in the industry and the community. Having worked as a machine learning engineer in different sectors, she is passionate about solving various life problems by building end-to-end machine learning applications, with aspirations to make large-scale impact on people and society. However, she has a strong focus on the intersection of artificial intelligence and healthcare. Please give it up for Precious Kolawole as she comes on to speak on a Muggle's journey to becoming a thousand. Yeah, please let the chat box be going. Come on, let's know we are live here. Drop some emojis, guys. Drop some emojis. Precious, you have the floor.
Awesome. I was trying to unmute myself. Thank you. Okay.
No problem, Precious. Would you be presenting?
Yes, I have my slides.
Okay. So stop sharing now.
Awesome. Okay. Oh, can you see my screen?
Yes, Precious.
Okay, cool. All right, everybody. We are still okay. We are in the afternoon. Good afternoon. I'm Precious Kolawole. I'm from Nigeria, and I'm a machine learning engineer. And I tell people I have interest in the intersection of AI and healthcare. All right. So without further ado, I don't want us to waste time at all. Let's get started. I think the topic has been introduced already, so let me just dive into it. All right. We've all actually been hearing about data since this event started, and from the very impactful session from Mary, I also learned a lot of things. So I want us to talk about the rudiments, like the problems we are facing in the data world, before I now dive into how somebody as a Muggle, somebody who doesn't have any understanding of what data science is all about, or what anything data is all about, can become a professional, an industry-ready professional. All right. Somebody said something one time, and then they said data is the lifeblood of digital economy. They said it can give insight, inform decisions, and also deepen relationship. And as we all know, data can be brought, it can be sold, it can be shared, and even stolen. So all those things, they suggest like what data is specifically about. And then when I thought about this, it happens to be true. But organizations, because most data scientists, we want to work for companies. And then these organizations, they lack the skills and technologies to use data to gain an edge over competitors. And even at times, I think there was a report one time that said 3 out of 4 companies haven't employed a data person. And then even those that employed a data person, only 1/4 of them are using these employees competently. So with all of these things, and this report was like in 2015. Now, recently, Google, Facebook, Microsoft, on and on like that, Shopify, everybody just wants to get on this bandwagon, which is data science, machine learning, data engineering. And still talking about the problems I mentioned, companies, they are often confused about the type of data professionals they should get on board, data professionals to work on their data requirements. And even it is hard for people transitioning into the skills, into the field, to know the skill sets required to meet the expectations of the industry. So as a beginner, it's actually very hard to get the general understanding of different job roles, because at times a company you get to see data engineering, data analyst, data architects, data of different sorts. So it's hard for beginners to understand the different job roles, and even harder to when they are looking for what fits their professional ambitions. So we are going to solve this problem here. We can see the slide. The CEO is like, somebody find me a data scientist, and then the data is wrapped. If you don't review some insights, I'm going to be forced to slice, dice, and drill. Many companies are confused. They have their tons of data they need to work on. So now let's dive into how you, as somebody who has no understanding, can solve these organizations' problems. All right. So here is my topic: a Muggle's journey to becoming a data wizard. Interesting. Now, the slide says, is this obstructing? Let me take it out. Let's say you want to save millions of data, you just push this button here. That is, if you want to dive into it, this is the right time for you to learn. Okay? So we have all of these things here, and I categorize them into two different parts. The first one, the technical side of things, and then the soft, that is, the soft skills you need to learn to become a wizard, a data wizard. And then they are all listed here, and we'll get to talk about them one after the other. Let's dive into it. Yeah, fundamentals of data science is the first thing you really have to know about. And then most newcomers in data science, they do what everybody around them is doing. Like they go straight into applying machine learning techniques like linear regression, random forest, support vector machine, without even understanding the basic. So I believe it's all like, it is the fault of this generic build machine learning models in 5 lines of code. I don't know if we must have been seeing things like this online: build machine learning models in 5 lines of code, how to become a data scientist in 3 months, things like that. There are many, but these things are miles away from reality. First and foremost, the important skill you need is to understand the fundamental. That is the difference between all of these concepts. The difference between data science, business analytics, or data engineering, the common tools and terminologies, and also you should be able to at least differentiate supervised and unsupervised machine learning, and then know the difference between regression and classification. Those are just like examples. All right. So now let's dive into it. The second thing is our statistics and probability. You know, many people in school, they don't like statistics, they don't like probability, because they believe it's mathematics based, and most people, they don't want to learn the mathematics angle side of things. But it is actually essential. It is an essential concept before you can start building high quality models or anything you want to use your data on. All right. And then we know machine learning starts out as statistics, and then it advances, because the concept of linear regression, as I mentioned earlier, they are age-old statistical analysis concepts. All right. And then for you to know this part very well, you need to learn what I call descriptive. You know, as I'm talking about all of these steps, I will mention the things you need to learn under them. This part is statistics, and then we have descriptive statistics, or in the aspect of mean, median, mode, variance, standard deviation, and all of those things. And then we have the various probability distributions, the samples, the population, the skewness, inferential statistics, and hypothesis testing, and so on. All of these things are vague the way I'm saying it, but it's not like the mathematics you learn in school, because you do the coding aspect of things, and it's a lot more easier. This person on the slide is a little bit frustrated while learning statistics. I don't know, many of us, like I said, we don't always like to learn statistics and probability. So let's just have this learning mindset by the time you want to dive into it, and trust me, it's going to be like a piece of cake. So the next thing is programming knowledge. You know, programming is the best way to communicate with machines, and you don't need to be the best in programming for you to become a data wizard. All you need is to be comfortable with it. So people will be like, how many years do I have to learn? For how many years do I have to learn Python to dive into the data analysis part of things? but you don't need to learn for a long time. You just need to be comfortable. And then you now have to choose the best programming language of your choice. That is, we have Python, R, and Julia, which are mostly recommended for data works, all right? And then the differences are clear, and then you can also make your research online as to the one to go for. The way Python is, which is what I always recommend, it's like a multi-purpose language. Having multiple libraries, it allows you to work even far beyond data. You can dive into software engineering part of things with the knowledge of Python. But R itself is specifically for statistics and visualization, like very perfect when it comes to statistics. And then we have Julia, which provides is like the best word of the two, of both Python and R. But the thing is, you can make your research, if you want to dive into MLOps or the technical part of things, I would definitely recommend Python. But if you are the statistical person, analysis person, visualization person only, then you can start thinking about R. But trust me, Python is the most used. All right. So now let's talk about data manipulation, which is the next thing. Data manipulation is just a great way a great thing that separates machine learning projects from the rest. It is like data wrangling and data analysis. Let's take for example now, you are trying to travel and you are packing your clothes in your luggage. What will happen if you throw all of your package, all of your clothes? What will happen if you stack them on top of one another? If you stack them on top of the other, that is, it's going to be neat, it's going to be clean, and then it's going to be fine. I mean, when I say stacking, that is, you iron them, you fold them right, and then you pack them, you put them in your luggage. But because, let's say, because of the time constraints, to start folding everything together, that means your clothes will get rumbled, they will get spoiled. So that's where our data manipulation is functioning. It allows you to get the best out of your data. And then to be very good in this part, it takes a lot of time to learn data analysis and data manipulation. And everything you need to learn lies between Excel, SQL, Pandas, the Pandas library in Python, which is very, very essential when it comes to data analysis. Now let's dive into data visualization. Data visualization is actually the sweetest, like the most fun part when it comes to data. I'm not the analysis or the visualization type of person because I'm into the technical side, like the core technical part. But trust me, data visualization is the sweetest. Because it allows you to build story from data. You know, people, it's hard to understand things understand numbers, figures, values. It's hard to understand those things. But when you see charts, when you see pie charts, when you see histogram, when you see bar charts, you see scatter plots, and just hovering on those charts, you get to understand, my data contains more females than male. So that's like the best part of our data, of working with data, and it allows you to communicate effectively to stakeholders, to friends, to organizations you are working for, and many more. All right. And then we have many data visualization tools. We have many of them. When it comes to Python, we have Matplotlib and Seaborn. Matplotlib and Seaborn, they are very, very good when it comes to data analysis, but they do. But we have other softwares that are very, very interactive, and that's like Tableau, that's Power BI, and Plotline. These three visualization tools are very, 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 very interactive. So you can dive into them one after the other, one step at a time. You don't need to rush, all right? So now let's dive into the next thing, which is machine learning. You know, machine learning is just like the part that gives inner satisfaction. It allows you to observe patterns, learn from those patterns, and use what your model learns to make predictions. And when I talk about machine learning, people think machine learning is a little bit vague, but it is not. As you dive into it, you get to understand it better. We can see this slide here. Madam Zaza is a fortune teller, and that's like machine learning, because machine learning sees the future. It tells you what's going to happen with you just working on your data, with you just generating predictions from your data. And then, do I have any message in the chat? Okay, none yet. Okay, so let me proceed. So the machine learning side of things, anytime I'm explaining machine learning, I try to use real life scenarios. That is, or for example, now let's say a baby is in the kitchen, and I like to see my face. Okay, let's take this way. Okay, let's say a baby is in the kitchen, and then the baby is sees a candle flame for the first time, for example. And then, you know, babies are always very, very curious, right? And then let's say the baby sticks his hand over the candle flame. And as expected, the baby will cry due to the pain from the candle flame. Let's now say 2 days after, this same baby is in the kitchen and the baby is seeing a stove top for the first time again. You know, stove top, it will also have the red light, the same way as candle. And when the baby sees this thing the second day, the baby remembers the incidents of the previous day, and then connects the dot of red and bright, which is the color of the flame from the previous day. And then after connecting the dots, the baby realized, oh, this thing is going to hot. And then the baby withdraws his hand from the candle flame, from the stove top, sorry. This is just machine learning because the baby used the experience with the candle flame to make predictions on the stove top. Let's now say the parent of the baby says, oh, this is stove top, this is candle flame, they will hurt you. That's like explicit programming and not machine learning. Machine learning learns freely on its own. And then that's where the future is going, as said by Madam Zaza. All right. So we have the deep learning side of things too. If you are motivated by smart assistants, self-driving cars, many other AI innovations, that's like the best thing for you. And I didn't talk about what to learn when you are in the machine learning side of things. You have to start with all those small algorithms before you dive into the assembling ones for improving model accuracy and all those things. You can start with simple linear regression. I've mentioned linear regression a lot of time. Random forests. Then we have other small algorithms to decision tree support vector machines. And then later you can start diving into the complex part of things. Okay, cool. Now, back to deep learning. The concept of deep learning itself allows you have to like fully work with Python. Though we have other variants now, like you using JavaScript, but Python is still the most recognized. And then we have different aspects of things, object detection, computer vision, natural language processing, and all of those. So for you to start, you need to learn TensorFlow and Keras, which are like the fundamental. By the time you are very cool with TensorFlow and Keras, you can dive into the Python side of things and then start working with convolutional neural network and recurrent neural network. Let's proceed because of our time. Now we have the concept of big data. You know, due to the rise in the internet and social media networks, they have been boom in the rate of data generated, and they are very high in volume. They are very high in velocity and veracity. So these organizations, for them to deal with those data, they need to use the concept of big data. And then we have some tools specifically for big data technology, and that's like Hadoop, Spark, Apache Storm. If you want to dive into the big data side of things, you can make your further research as to the languages to learn. All right. So now we have model deployment, which is, like I said, is the most underrated step in machine learning lifecycle, because I'm part of different data science community, and many people have actually been learning data science for 2-3 years and they still cannot deploy their models. But let's say you are given a task by a client to build a machine learning model to predict customers that will pay back their loans or not, or to feature out the filters from the data. After working on this project, after getting your machine learning model, are you going to place your laptop and give it to the person? Oh, this is the outcome of my model. You can run this Jupyter notebook from the top to bottom. I don't know if we are majorly beginners or we have intermediate also. Sorry, I didn't make research on my audience very well. Sorry about that. If you're a beginner, the Jupyter notebook is just like the tool for running your data code, your pandas code. Let me just put it out for building models, right? Are you just going to place your Jupyter notebook and tell the client to run from top to bottom and see how the thing is predicting? No, definitely not. You have to deploy. And then I have to include software engineering, because if you have, I've worked as a machine learning engineer in different capacities, and it has always been requiring the knowledge of software engineering, not full software engineering per se, but for you to deploy your models, you need to learn some back-end skills. So at times, many people will say machine learning engineers are indirectly back-end engineers, so you need to learn some concepts like Streamlit to host your models, Flask to host your models, Django, we have Fast API, and you need to learn some cloud tools also, like Heroku, how to use AWS and the pipelines, AWS services, Heroku's or Google Cloud services, and also Microsoft Azure services. But you don't need to, they are all overwhelming at like hearing it at first, but you just need to take it one step at a time by just starting out with Heroku, Flask, Fast API, those easy ones. All right. So model deployment is very essential. Now let's dive into software or into the soft skills. Okay, I think I have questions. I'll attend to all the questions after the session. All right. Thank you, Shema. So talking about the soft skills, we have communication, storytelling, curiosity, and structured thinking. These things, they cannot be emphasized enough. Good communication is just as simulating as a black coffee, like I said earlier. For you to communicate, whatever you've derived from your data is very essential for you to become a data wizard. Communication and storytelling. You must be able to talk. When I started the data science team, I'm not I was the quiet type. I don't really like showing up my faces, speaking, and all those things. But trust me, you just have to, and it can be learned. Some people are natural, they are natural talkers. I don't know if that's the best word. Some people speak naturally, but some people, you have to learn it and get to understand it gradually. All right. So this not like myself, I learned it and it has been working. All right. So storytelling is very, very essential to communicate your insights, to even to get gigs. Storytelling, communication, they are very, very essential. And as a data person, you have to be very, very curiosity, because the data, on seeing your data in CSV format, let's say the structured ones now, CSV format, you get to, okay, if I plot this column A with column B, what's going to be the outcome? What are the possible things I will get from this? If I plot this plot of X independent variable to my dependent variable, what are the results? You have to be very curious, all right? And then we have structured thinking. Before you can get just exactly the way I've been explaining, before you can become a data wizard, you have to learn some things gradually, structuredly, from one to the other. That's like structured. It is applicable when you are working with your data as well. And the one thing I always like to mention is that you don't have to be limited to just data science. Data scientists or data engineers or data analysts or different fields, they are problem solvers, and you are expected to apply data science or your knowledge of data right now. Don't let me mention data science. You are expected to apply it to your field, because we are majorly problem solvers. You can come from the financial sector, from the agricultural sector, economics, dramatic arts, courses of different sorts. You can have different type of degrees. I personally am a medical student. You just need to think of ways of combining your data science to solve problems in that particular field you've gotten your degree from, or whichever. All right, so that's just something I wanted to ship in. Now, this part is saying not every data wizard does data science work. I know in this part of the world, like Nigeria right now, everybody is just about data analysis, data science. That's what people are just concerned about. But we have data engineering, which is like, getting the limelight. We have machine learning, getting the limelight, or data architect also. So you need to be familiar with all of these data fields. And like I said at the beginning of this session, you must be able to see the one that fits your professional ambition. All right. If you see yourself, like you are this core technical type of person, you can consider MLOps and machine learning. And if you just want to write, analyze and all those things, you can think about data analysts. All right. So data analysts, they are expected, I will just brush through them because of my time. Data analysts, they are like data detective, or they are expected to be very intuitive, data junkies, or with I figure it out mentality. Let me put it that way. I figure it out mentality. And then what they do majorly is they focus on data analysis and presentation of data. They provide reporting dashboard build KPI business performances and metrics. They evaluate business growth, and they should also have the knowledge of querying data from databases, because almost everybody in the data part must know how to get data from the database, both relational and non-relational type of database. And we have data architects too. They focus on the engineering and they manage stores, like data stores. And everything that resides in those data, right? And then for you to become a data architect, you just need to learn the big data side of things. And then also the knowledge of SQL, MySQL, Spark. I mentioned Spark for big data, all right? So they need to know how to manage their database and the engineering side of the database. Now, data science, it contains everything in data analysis, data wrangling, and them just working with structured and unstructured data. I know people most time confuse data science with machine learning, but I will explain it deeper when I get to the machine learning engineering side of things. So now for data engineers, they focus on engineering and managing infrastructures. Data architect is also very, very related to data engineering, to data engineers. Like data architect is kind of related to data engineer, all right? So, but one thing you have to know to differentiate it is that data engineers, they work with pipelines, that is CIC, the continuous integration, continuous development of their data. That is from the data source to how the data will be reaching the analyst. All the pipelines, they have to be monitored by the data engineer, all right? Now, talking about data or machine learning engineer, you need everything in data analysis, data science, and then the mathematics side of things, calculus, linear algebra, all right? Because all these linear regression models, they have mathematics. Though most people in Nigeria, they just dive into model.fit, model.predict. They fail to they fail to understand the calculus, the mathematics side of things. But for you to be a data wizard, you need to learn the mathematics side. All right. And for machine learning engineers, you must be able to interact with cloud services and know how to deploy your models, which is different from data scientists. Actually, organizations these days, they get to include data science. They get to include model deployment. When you see the data science, for example, now I applied for a role one time, it's been a while, and then the job requirements, I was told to understand how to use Microsoft Azure, Kubernetes, Docker, and those are like for machine learning engineers. I was a little bit surprised because I didn't have the skill set then. So those are the things you just need to like grow the way the industry is growing. You have to emerge. And that's one thing you need to understand too. You must be ready to change the way the technology is changing. Now we have MLOps engineer. They're like, they encompass everything in ML engineering and also the security side of data, right? And that's like the combination of DevOps, if you know what we call DevOps, or they encompass everything in that line. Now, we are talking about, the next thing is how to stand out as a data wizard, all right? I know the competition is very, because the way data is getting the limelight, we have many people in the industry. Many people are learning data science. People are spending a lot of time learning data science. And then you need to stand out as a data wizard. And then the first thing I will always mention is your GitHub profile. It means a lot, really. It means a lot. Your GitHub must show that you are a data analyst, you are a data scientist, you are a data engineer, all right? Your work should be shown. Actually, GitHub does not allow you to, when you build your model as, let's say, .pico file or .doblin or then as .hdf5 or .h5, and then you push on GitHub, it's just going to show as a big file. There won't be a way for you to view what's inside. That's because GitHub is actually limited to front-end engineers, back-end engineers, software engineers, and all those things. But we have another part of it, which is DarkSub. DarkSub is specifically built for machine learning people, for data science people, or for data analysts. You understand what I'm trying to say? We have DarkSub, and it allows you your notebook, everything will be seen. But if you've interacted with Plotly before, you see when you push your Plotly code to GitHub, it doesn't show the design. But dark source allows testing because it's specifically built for data scientists. But before you even dive into the concept of dark source, your GitHub must show that you are very skilled in that particular field. The number of commits, the pull requests you've done, companies are interested. And then Kaggle, I know most people in this side of the world, we start with Kaggle, like we learn Kaggle first. Oh, do I have, the chat is increasing. Okay, there are questions, right?
There are questions.
Okay, I have 10 minutes left. Yes,
Yeah,
awesome.
Thank you.
Oh yeah, you're welcome. So to quickly talk about Kaggle, many data scientists, we start with GitHub, right? With Kaggle, sorry, because you get to interact with different kind of data sets, work with other people, and see your model results. All right. So now Kaggle is just the best way for you to acquire, curate all those skills. Now, another thing is start a project. Many people, they are interested in getting certificates, but certificates are not going to help, really. Though they are necessary, but they are not they are not things that will make you stand out. Your projects will make you stand out. I said completing a personal project is 100 times more valuable than an online certificate. And many people will now be like, how can they find projects? Like I said at the beginning, you just need to look for problems in your field and try to solve them using your knowledge of data. I don't know if you get. If you are the type of person that likes cooking, you can get your Moodle to get all your recipes and predict the kind of food to build. It's very fun, it's very interesting. And then portfolio website. You know, your portfolio website also is going to showcase you to employers, all right? Without them even getting your CV, your portfolio website will be able to make justice. So now, the last thing is avoiding common mistakes people make while learning. And I'll quickly talk about it. The first one is assuming what you see in ML competitions is what real life jobs are. And that's very, very wrong, because in ML competitions, you see the data sets, they are already clean, they are structured. They give you the CSV file in competitions like Kaggle and Zindi. They give you, those are the kind of data you work with. But when you join organizations, you will get to work with their database directly. And then if you don't now understand your SQL very well, if you don't understand Postgres SQL, it will now be a problem for you to interact with all those databases and get your data out. So the next thing is using too many data science terms. Some people, when they are having data interview, they are trying to get a data role, and they're having the interviews, you just see them talking about, I did one classification, I did one regression, SG boost. Those are not what you need to explain. You shouldn't use too many terms when you are having your interviews with potential organizations, all right? Break things down and let them understand how you can use it to solve problems. Okay, now, it's the next thing says, want to be a data scientist, don't start with ML. Yes, start with, like I mentioned, from the beginning. I've explained this part. You don't need to dive into machine learning straight. Machine learning is like the subset of AI, and that's not where you are expected to start from. And then preparing only theoretical without applying them. Yes, many people learn the practical side without knowing the theory, but some people are just based in the theoretical side of things. But you need to have wide knowledge in both areas. As much as you know your theory, you need to know your practical side of things too. All right, so that's pretty much everything. Yeah, I'm there on Twitter at Presidio, and you can reach out to me on LinkedIn. So let me deal with the questions, all right? Is anybody going to put that, or I can read them out myself?
Okay, I'll that question. Thank you so much.
Right.
This question has really been insightful. My notes is full. I've been taking you touched like basically almost everything, from starting, how to start, careers, how to stand out. This is really amazing, and I'm sure our participants they've learned quite a lot. So let's go to the question. Thanks, Peter. Let's see. Okay, we have a question from Esther. She says, can you mention how to start with deployment phase and some open source tools?
Okay, awesome. Let me take that first. Talking about deployment, model deployment, okay? You need to get started with knowing how to save your model. Like after building the model, you must be able to save it as .html or hdf5.pickle.jobly. You must be able to save it. Then after saving your model, you now start interacting with the applications, the languages that can make your model to be hosted, that is to be accessed as a web application. And there are libraries like that, not libraries this time, languages, and that's like Flask. I started with Flask, and I bet you Flask is very, very easy to learn. Flask allows you to open a web service, a web application, like a local host in the sense. So in that local host, you have a function where you pass your model, your machine learning model inside. And then the function will get to read the content of your data. And then you pass in your return statement. That is what you want your model to return anytime it has been triggered. So Flask is very, very recommended. Immediately you know how to save your model, you can start learning Flask, right? So after learning your Flask, that's just what will make it as a local host. The next thing is to host it on a web application, like a server, all right? You need to host it. That is, local host is still on your computer. You need to be able to generate a URL that can be accessed by a third party. And that's why that's when Heroku comes into play. The way Heroku is, it's free, but you are only limited to 5 more. You can only deploy 5 applications. So you can learn how to deploy on Heroku. So from saving your model to learning Flask, after learning your Flask, you deploy your model on Heroku. And then Heroku generates a URL for you, and that URL can be accessed by a third person. Now, aside from Heroku, we have Streamlit. Streamlit doesn't allow you to use Heroku. Streamlit is also different, and it encompasses what's inside both Flask and Heroku. Streamlit generates a URL for you too, and then you can write your function using Streamlit and then get your final URL with Streamlit. Okay, so but still, before you can learn Streamlit, you still need to know how to save your model. Okay, now after being comfortable with those two, that's when you can now start thinking of the cloud services like Azure, AWS, and Google Cloud. Okay, can we still hear me?
Yes, loud and clear.
Awesome. So have I been able to, and open source tools? Yes, all of these things, they are actually open source. All of these things, they are actually open source. If you check their documentation, they are open source, and then you can get to interact with them. But all of these ones I mentioned, they are enough for you to host your machine learning models. Okay, and then if there is anyone that comes to my mind, I would definitely mention it. But I can't come up with one at this point. Okay.
Thank you. I hope that answers your question. We have another one from Faith. She says, if someone wants to become a machine learning engineer, do we have to learn data science first?
Yes, big yes. You need to learn data science. You cannot become, it's not really data science itself. For you to become a machine learning engineer, machine learning actually encompasses both data analysis skills and data science skills. You need to be able to work with any kind of data to be a professional machine learning engineer. And then data science, to everything in data science, you need to learn them. You are muted.
Yeah. I said, of course, like it's steps, so we take it step by step. Okay, on to the next. Caleb says, Ma, as a desperate beginner coming into the world of data science, what advice would you give to me? What aspect of data science would you advise that I start learning from?
Okay. As it, you don't need to be desperate. Actually, you just need to have this. You must be able to persevere, and because tech is hard. Like I always mention, tech is hard. But if you have passion, it will always drive you. Okay, so you don't need to be desperate. The passion is going to drive you. All right, and then which aspects I would recommend for you to dive into first? You have to start with Python, like I said, your programming language. You need to learn Python first. Now, data engineers, that's like the funniest thing. Data engineers too, they can work in all capacities. like in all the capacity. Or machine learning engineers, they can work in like as a data scientist, as a data analyst. Okay, if just MLOps engineers, they are kind of different. So you just have to follow the move with the flow. After learning your Python, just dive into the mathematics side of things. Learn statistics, learn probability, learn linear algebra, and a little bit of calculus. You don't really need them though, but just have the understanding. Because once you start diving into deep learning, the mathematics prerequisite will now be needed. All right. So after learning your mathematics side of things, you can now dive into data analysis. That's like the flow. Using pandas and all those languages. You can use pandas to deal with your data manipulation now. And then you learn data visualization. I think I explained, like my slides also follow how to transition, okay? So just pick them one by one. After data visualization, then you can now start thinking of data science and machine learning. And by the time you get to that stage, even you yourself, you now be able to navigate your path yourself. Or do I want to dive into data engineering next? Do I want to go into the deep learning side of things? Do I want to become a software engineer with my machine learning skills? You get? So that's pretty much it.
Yes, I agree. Data analysis is usually like interesting. Where from there you make your research and then find out what you're more interested in. Thank you so much